Well, good afternoon and welcome to today's webinar where we're going to take a look at a simulation extension for Creo, simply titled Creo Simulate. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI. And today, leading the overview and live demo of Creo Simulate is Andrea Francis, who is an Associate Solutions Consultant and Applications Engineer with PTC's Virtual Center of Excellence. So if you have any questions during the webinar, please type those into the Q&A box. We'll try to answer those as we go along. They will definitely be answered at the end. And yeah, I know Andrea is going to cover this, but what the important aspect of having a tool like Creo Simulate is so that a designer and an engineer can use this tool up front so that they can design not just for form and fit, but also for function. So it saves a lot of time from sending a part or an assembly downstream and then having it come back early to be redesigned. It saves a ton of time. And it's not an overly complex tool to use, meaning that you don't need to be an expert in simulation to use it, but there absolutely is some training involved. So with that, Andrea, you can take control and lead us. So thanks for helping us out today. I appreciate it.
Cool. Thanks, Rob. Well, hello, everyone. As Rob said, my name's Andrea. I will be walking everyone through what Creo Simulate is. We're going to go through maybe some of those problems and why it exists as a solution, what it is, its capabilities, and then I'm going to actually show you how to set up a simulation in it. And to start, we're going to start with those challenges or problems that we see out today with analysis, with engineering, and just in general, really. With analysis, it's something that is done mostly by experts. There are specific people that know how to set up the studies, how to set up the meshes, all of that type of information. And it's usually done to catch a problem. You want to, or either to validate the design that you're making. You want to make sure that everything that you've designed works, achieve goals or requirements that you have. And usually it's not used to innovate or something like that. You want to get the product to work, not really try to get it to the most ideal option possible. You're trying to do it in the later stages of the designs. It could be expensive as well if you haven't caught any errors or any flaws up to that point. Leads to a lot of rework. You have to go in as an engineer back and forth, trying to work things out, checking back and forth with the analyst to get that design idea. Now for this solution, it's to really address all of these different challenges that we've seen today. With simulation, you don't want as an engineer or a designer have to worry about constantly going back and forth between analysis. You yourself want to be able to go and perform analysis, but also some useful analysis. You want to be able to guide and improve that product performance that you have or optimize on it. And that's where the solution comes in. It's a multi-discipline CAE tool, which as an engineer or a designer, you can go in and simulate your physical behavior of your model, understand and improve the mechanical performance of that design. If we want to focus on what it does, it allows you to perform structural and thermal analysis. You can look at your stresses, your deflections, your frequencies, heat transfer paths, and multiple different factors. And what's great about it is it's integrated into Creo Parametric. You don't have to worry about jumping into another software or into another window. You don't have to learn something entirely different than you're used to. You're working in the same environment as a designer, as an engineer, building up your design, setting up your studies, and overall, you're using it to make better decisions at the end. You want to use it to drive how your design is made, how you want to also optimize onto the design. You're not just okaying something or trying to just get an answer out of it. You want to get the right answer. What's the best way to do this? Is my product going to be stronger? Is it going to be lighter? What's the best way for me to optimize on this specific component or on this variable? And how do I hit those specifications and goals that I want to hit for my project? In terms of capabilities, there's a lot of them. You can perform many different types of analysis. Depending on what you're working on, there's really a full suite of analysis capabilities. You can do static structural analysis, buckling, fatigue, for example, dynamics, nonlinear contacts. There's really a lot of capabilities that are in it. And the reason behind that is because it's been a tool that's been in Creo for a very long time. It's a very mature tool that we've built throughout the years. We've improved on, we've added a lot of different capabilities in it to make it easy to use and to make it something that you can use to perform different types of analysis for various situations that you might have out there. As far as setting up the studies in it, it's very straightforward. There's a very straightforward workflow of you would choose the type of analysis that you're performing, then you would go about choosing your loads, your displacements, all of that type of information, your constraints, your materials, and then meshing. For the meshing, there's a various ways you can do it as well. There's an automatic way where you could let the system do that work for you, optimize it, and there's also advanced meshing capabilities. You yourself go in and refine the mesh, maybe in specific locations or areas that you want to tweak and focus on. And there's also support for solids, for shells, beams, springs, and masses, all of that. As far as optimizing, with this tool, you're not just running analysis and getting results. You want to be able to act upon that result as well. So you can conduct optimization studies or feasibility studies as an example. It's not just about making sure that the product or the model checks all of those boxes, but also you can act upon those results. So let's say that you have a model that you're working on and you have a specific thickness for that model. What is that best possible thickness? Am I accounting for strength? Am I accounting for weight? Can I vary other variables or properties that I have to get to that best possible answer? And that's what optimization studies are all about. You can let that system run those for you, and then you can act upon those results. And as far as taking a look at the results as well with the simulation, you can take a look at them in multiple different ways. You can set up templates on maybe I want to view multiple different variables into my results. Do I want to look at my stresses, my displacements, my deformations all at once? Do I want to have animations on there? Do I want to create reports or do I want to query my results as well? Can I query specific areas onto my model, look at specific values? Do I want to plot certain graphs, vector plots, isoplots? I can do all of those from within the tool. And that's what's great about it. Now that we've seen that overview of all of the different capabilities and we know why it is a very beneficial tool, let's actually jump in and start creating a simulation within a Creo. And we're going to be using this machine press model that I have over here, and we're going to be focusing on to a bracket. With this bracket, we want to make sure that it's going to hold up our weight for our machine press and make sure that it hits all of our different goals for stresses, for displacement, for deformation. And we're going to be using Creo Simulate to do all of that. So as a start, you can take a look at the top of the screen. We have our ribbon with all of our different capabilities on there. To start working in here and how to set up that study, you can follow the way that the ribbon is placed into Creo. So you would start by choosing the type of study that you want to do. Do you want to do a structural study? Do you want to do a thermal one? You can choose that and then follow from left to right all of those commands for you to set up that study and look at your results. So the next step would be for us to look at our constraints and our loads. We have multiple different options for all of those. As an example, for the constraint, we can set pin constraints or ball constraints. We can have a planar displacement. We can choose that magnitude, the units, and the same thing applies for our loads. What forces do you have onto that model? Where are they located? What are the moments? Do you have any pressures? Do you have a bearing, maybe certain temperatures? Are you taking into account gravity? Do you have a certain distribution that you want to put in here? Is it going to be at a point or is it not going to be? And then set the magnitudes, set the units. You can even preview those to make sure that they are set up the correct way that you need them to, and then you're ready to go. Next would be our material, but now I have it already set up for us. So you can assign the model that you're working with, the specific material that you want to have, and then you're ready to start running your study. For the different studies that we're working with, let's say that we have these different options that we want to have. We can work with static, modal, buckling, fatigue, dynamics, and just for the sake of today, I'm going to go through a static study. Even in here, we have different options for us to choose from. You can choose the method maybe that you want to utilize for that study. Do you want to do a multi-pass or do you want to do a single pass? And there's different ways that you can also play with the conversions, the polynomial order to really look at various ways that you want to simulate your results. And once all of that is set up, you can run your simulation. You'll be able to view how the system is computing all of those results, and you can get a status of having the results being completed, and you can take a look at them. There are these multiple templates that you can set up to view different types of results. Do you want to view the displacement? Do you want to view the stress? Anything that is important and relevant to you, you can set up a template within Creo Simulate that you can either reuse on and on across your multiple projects, or that's maybe the standard way of viewing your results. You can animate those results as well, view the deformation on here, the stresses, and even with the legends, they are very configurable. So you can set those up however you'd like. And for the templates themselves, reuse them across your different projects, your different analysis that you're running, just as a way to save yourself the hassle of having to reset those up from scratch. And let's say with our results currently, as an example, we have our stress value being too high for our sake, for the goal that we want to achieve onto this bracket, that value is too. Now we know that those results, we know what values we're at currently, but now we can act upon it. What we can do within Creo Simulate is we can run sensitivity studies, we can run optimization studies for us to act upon those results and make changes, modify, and improve that design and really achieve our goals. For the sensitivity study, what we can do is we can calculate the changes in that stress that we're working on when, let's say, we vary measurement onto our fillet as an example. We can set a range of values that we want our study to iterate on, and then we can have it graph our stress versus our range plot for us to take a look at, oh, what is my most optimal fillet size in this case for my ideal stress? That's a way to do it. You can define all of that and you can graph all of those, and you can save the sensitivity study as well if you need to. With this, you're able to determine which appropriate size it is that you need to have, in this case, your fillet to be, instead of you doing it all manual. You don't have to iterate on that. You don't have to waste any time doing all of that. Let the system do it for you instead. And with that capability, you can do it on one variable, like in this case, or you can take it even a step further by performing an optimization study. With an optimization study, what you can do is you can have it look at one or more variables that you have. Maybe you have these multiple dimensions onto this bracket that you want to study. And you can set a goal or even multiple goals within the optimization study and let the system compute that for you. You can do optimization, you can do feasibility studies, and we can set those goals directly from within the system. As an example, let's say that we are still working with our maximum stress, but now we want that maximum stress to be a specific value. So we can set that as our first. We can add another one as an example. Maybe your displacement magnitude also has to be another specific value. So we can have Creo understand, oh, these are my design limits that I want you to run an optimization study for, while taking into account multiple different variables that I have. These could be the dimensions as an example onto your model. We can start with the fillet, but it doesn't just have to be that fillet. We can have more than that. Maybe we're looking at the angle as well, or the dimensions on here, maybe the thickness or the length of certain parts in here. We can set all of those up directly and even set individual ranges for them. So we can have Creo take into account all of these different variables and measurements at once and compute the best possible solution out for us based on the design limitations that we've set for it. And that's what we want. We don't want just to be able to run analysis, but we also, as designers and engineers, want to have a way for us to act upon it without having to take long times, do iterative sort of tasks for us to get there. We can let the system do all of that for us. And in the same way that we run our sensitivity studies, we can run our optimization studies. Once we have all of those information set up, we have our design limits, we have our variables all set up, all of our different ranges. We let the system compute the most optimized solution for us. And then what it will do in the results section, it would give us the new model for ourselves to take a look at. So if we go in and navigate into our results, the shape of this bracket will be completely different than what we've had it as before. The reason behind that, the optimization study, because it optimized for all of these different variables based on to our stress and our displacement magnitudes that we've set up for it. So you can really tailor your different projects, do a lot of automated work in here instead of doing it yourself manually. And that's the beauty of working with this tool. You're running analysis, but you're also acting upon it. And you're getting a most optimal product or model at the end of it, meeting all of your different design goals. And yeah, that's it with the demonstration. With Creo Simulate, you're really able to take it a step further with your simulation. You can leverage all of your different capabilities as a designer and as an engineer. It's a tool built into Creo for you. You don't have to be an expert at doing everything within your simulation. There's a lot of these different tools that facilitate you using it. And the point of doing all of this is really discovering flaws, not having to worry about maybe using physical prototypes. We see a lot of cases where a lot of people or teams utilize physical prototypes to check onto the performance of their models. But you don't have to do all of that. Reduce your material cost, take into account strength, take it into account weight, and really improve your cycle process within your models. So get them out there, act upon them, and utilize all of these different capabilities from within Creo right at the tip of your hands. And yeah, that's it.
Awesome. Thank you, Andrea. I
Yep,
appreciate it.
no problem.
Good job
Do
today.
Thank you.
So I want to thank everybody for being on. I'm going to have the recording uploaded to our YouTube page by tomorrow, and I will send out an email with that link so that you can watch this again at your leisure and share with anybody else that you feel would be interested with this. Next Thursday, the 29th, we are going to have a webinar focusing more on the wind chill side of the house. With ThingWorx Navigate and how these applications within ThingWorx Navigate add better visualization and make things easier based on a person's role and what they want to see, so they can get cut through right to the information they need to see quickly and easily with wind chill. If you have any questions or want to see a more detailed demo on Creo Simulate, Creo Simulate Advanced, Creo Flow, anything Creo, anything wind chill, anything PTC, augmented reality, you can contact us at info@3hti.com, or just respond to the email that you were sent as the invitation to this webinar. So thanks again for being on today, everyone, and we look forward to seeing you next week. Take care.